Hello guys, welcome to a new video of Boolean Algebra, the fourth episode in a row and also the first episode of the series. Don't worry, this is not the last episode on my channel. For now. Ha 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 ha. Anyways, this video is about encoders and decoders. What are they? I know, but do you know? And also, what are they for? They actually have multiple uses. I only thought they had one uses about few minutes before I was recording this video. But we first need to talk what are encoders and decoders. Let's see it. So let's take our items. Redstone. We only really need and roll just for the example. So imagine you have the bit string 101 and I want to convert this to numbers, but how? Well, I use a decoder. I decode the 101 string and turn it into a 5. Ta-da! So, for encoders and decoders, you can use a complex method to actually calculate exactly what it is, like how we know what bits are. Or you could use the simple method, a multi-if chain. And we are going to do the simple method because it's smaller, cleaner, and, well, just more useful. Because I don't think you want a crazy mechanism for just converting bits into numbers and numbers into bits. So let's get right into it. So first we need a input here. So let's have 1, 2, 3, 4. So you have A, B, C, and D. Now let's take some redstone. What we want to do is we want to convert A, B, C, and D into a bit value. But since 0 is nothing, we can remove the last one. That would be 0, but it's always 0 if none are on, so we can remove the last one. So imagine, so first what you want is you want to put a NOT gate on all of them. I'll later explain why. So we have our NOT gate. Let's quickly put these more out of each other, easier to work with. So we have our NOT gate. Now what we do is we put some redstone dust on top of it, like this. And then here it's also a NOT gate, which we already have. But here there are also the redstone lines. Only on these levers. Levers. Oh, do you actually call it levers or do you actually call it levers? I don't know. But anyways, now since we have this done, we also want, well, I'm stuck, redstone lines moving into these. The same size as all the wool. You can actually remove the last part. Well, if you want to, I recommend you don't, because it just looks more like regular like this. So then, when this is on, what we want is that we want the bit value 0, 1. So, which one is that? Only this one. So, what we do is we put a redstone torch here. So now we have 2. What do we want 2 to be? That's right, only this one. So we put it on this side this time. What do you want 3 to be? That is correct. Both of them. Of course. How bits work. So this one and this one. So now, this is our little mini encoder. It encodes. So, test it. Let's first do the 1, and it shows the bit output 0, 1. Let's do the 2, and it shows the bit output 1, 0, like 2. Let's put the 3, and it shows the bit output 1, 1, like it should. Let me show you why. When we put this redstone torch, it deactivates these, causing these redstone torches / not gates to turn on, causing this 2 redstone lines doing this. Now, this is basically an if chain. If this is on, do this and this. If this is on, do this and this. And if this is on, do this and this. It's basically a multi-if chain, huh? And there are actually much more uses for this. Let's quickly make a 3-bit one. 1, 2, 3, 4, 5, 6, 7, 8. 8 is 3-bit, and remove the last one. So, let's quickly put a level here. You can also transfer data using these things. Let's put it like this, like this, like this, like this, like this, like this. You can also transfer data. Let's take this, put a redstone torch, like that. And I'll see you when I'm done building this, because it does take quite a bit of time. Alright, now the if chain part. So many sections, bro. Ooh, I forgot something. It needs 3 lines. Now we also have to build that. Yeesh. This is gonna take a while, bro. Okay, we have all of the 7 bits done. This encoder takes 8 inputs, tinies it into 3. And we can send it over. We can also use repeaters to redo the redos. I think it's better if we put an instant repeater over here. Because imagine you want a input from the back. So let's quickly make it like this. Another repeater, another repeater, another repeater. Like this. Like this. And then what we have here is 8 inputs into just 3 lines. But you might think, but we need the original. Well, my answer to that is, well, if you want the original, you need a decoder. I will explain to you what a decoder is after we test how satisfying this is, bro. So satisfaction. Satisfactionous. Satisfaction. Way too much satisfaction. Plus, if your encoder becomes too big, in between these lines, under the blocks, because they're guaranteed, you can also put repeaters like this, which can extend your encoder infinitely that way. But I don't recommend you make the encoder too big, because you can use multiple for the same encoders to not have too big of a encoder. I'll tell you how to do that in the next episode, but first we need to talk about the decoder. It turns bits back into values. let's see how to do that. So, you still need 3 inputs. 1, 2, 3. But for the example, 2. Now, what we do is we take them like this and we put them up here. Then we go back down and go back up. Go back down and go back up. You might think, what is this, bro? I'll explain it later. But then here is the here is the starting. Alright? So 1, 2. We want actually 4 possible outputs, because here in this case it is possible to have 0. It is allowed to have 0. So 1, 2, 3, 4. And now we have to do the same with the other side. Ugh, this takes forever. Okay, this is actually taking forever, bro. Speed it up! Okay, I was very impatient, but now what you want to do is you quickly have some redstone here, here, and skip this block. It's going to be soft power, and it's going to add repeaters. We want to add repeaters on all of these. I know, wow, double speed so quickly. Actually, 100% speed is also quick, but we are here. And then what we want is, example, if only one is on, what we want to do is we want to output this one. So we put it like this, and we give redstone like that. And then what you want to do is not do this, because you just want it to be this one. So we still have another repeater here to continue the signal this way, but this repeater is replaced. That means that the redstone does like this. So then it can activate too high. Come on. Come on, bruh. Well, I guess we need to make the redstone base level a little bit higher. Like this. Now I know what you're saying. It's on, broski. It's supposed to be off. I'll explain that later. But then here we also want one. But you might think, well, this also turns it on. Well, I was actually right before. Sorry for the confusion. And then you actually want this one to be a repeater real quickly. And you want the redstone to go around like that. But for now we don't want that, because we want it on the first area. So let's quickly put it back like it was before. Like this. Decoders are actually a little bit more complicated. But for now that doesn't really matter. Because if we build it and it works, it's good. So then you repeat it here, but then this time we want it on this side. By the way, I recommend you put a block under here. It's just more comfortable to work with. This time we put it on this side, and then on both scenarios it's on both. Ha! I'm funny. Kinda. Then we have it like this. Then we have it like this. And then we also want one line here. I'm almost done. Okay. And then we also want the line here. So that means that we basically have to more do like this. Wow. So that means that this can go away. Ooh. Like this, like this, like this, like this. And then here we put redstone. Yay, yay, yay. And then here we simply put redstone torches. And then we have our output. It can be 1, 2, and 3 with the bits. So you can turn a bit into a decimal. For example, ooh, I kind of forgot something. I think it's better if we switch these. Like this, like this, like this. And like this. Because I think it's better if we read it accurately. Like this, go around, like that. I think this is better that we switched it. Because now, this is actually the 1. So, 0, 1 equals 1. 1, 0 equals 2. And all 3 of them equals 3. So, what you can do is you can make this encoder bigger to have 3 bits and 8 decimal values. And you can also make this string longer and then put it there to have the bit into this and then back into decimal to make less wires. But what you can also do is you can use this to have your fill adder in bits and encode it, decode it to look like numbers, which is cool. But to actually make and combine these two things, I would leave it to you. And until then, bye bye!